Here's a problem that shows the mean value theorem. So let's take our function f of x to be equal to sine of x on the interval 0 to pi halves. What I want to do is find the average value of f on this interval, find all the points where f of x equals the average value. Okay, this problem makes sense because the mean value theorem says there's going to exist some c in the interval where the average value is equal to f at c. Starting with a definition, okay, if I have the interval AB, my function f of x, then the average value is equal to the length of the interval, b minus a, integral a from b over f of x. So if I plug in what I have for my definition of the problem, length of the interval, pi halves minus 0, and we integrate from 0 to pi halves of sine of x dx. Okay, take the antiderivative of sine of x. That's going to give me minus cosine x. Okay, to check on that, derivative of cosine is minus sine, so derivative of minus cosine just gives me sine, so that agrees with my integrand. We're going to evaluate from pi halves to 0. So remember, cosine is just the x value in the unit circle. So at 0, the x value is equal to 1. And at pi halves, the x value is equal to 0. So now, what do we have? We have our 2 over pi. Okay, at pi halves, we get a 0. At 0, I get a minus 1. Take the difference. So my average value is going to be 2 over pi. Now, 2 over pi is roughly 0.637. So I can draw the picture. First, I draw in my sine going from 0 to pi halves. So sine maxes out at pi halves. That's the y value. The biggest we can get is a 1 when we're at pi halves. Draw in the sine. And then I draw in my 2 over pi, which is really close to 2/3. Draw our line across. And then we're looking for the c value that gets me to this 2 over pi. Well, this is the definition of inverse sine. If I want to know what sine of x gets me to 2 over pi, that's the same as saying, find me sine inverse of 2 over pi. Plugging that into my calculator gives me 0.69 radians, and that's what we were asked for. Of course, I can check this. I just stick 0.69 radians into sine, and out comes my 0.637, which is roughly my 2 over pi, as promised. Okay, let's remind ourselves of what the mean value theorem is actually saying. So there are two objects here. We have the area under our curve. We have the rectangle with height f of c, base b minus a. So what the mean value theorem is just saying is, you take the area under the curve, pretend it's like an ant farm, it's made out of sand, you shake the thing up, then what's left over is going to be a leveled off rectangle. All the mean value theorem says is that the top of this rectangle has to cut the graph of f somewhere.